Video problem 52, shapes of molecules and ions, VSEPR theory. Determine the electron domain geometry and molecular shape geometry of the compounds in video problem number 51. Let me go grab those real quick and bring them back over here. So here they are. Ooh boy, this is a mess. So what I'm going to do is I'm going to pause the video real quick. I'm going to copy these and then transfer them on over. So give me 1 second. Okay, so here they are, the structures. So electron domain geometry and the molecular shape / geometry. So the electron domain geometry is basically you have to look at how many sides of the atom are being occupied. So for instance, in this case with CH4, we're occupying 1, 2, 3, 4 sides. Since we're occupying 4 sides, there are 4 electron domains that are possible. So the electron domain geometry has 4 possible places. So the electron domain geometry in this case is what's called tetrahedral. Here's the actual look of it. Now that's the electron domain geometry. The molecular geometry is also tetrahedral because it's only surrounded by atoms. Okay? Now look at CH3Cl. It also has 4 electron domains. The idea of electron domains is actually really important. So since it has 4 electron domains, it's also going to be tetrahedral. And since it's only atoms, that's just what it is. It's tetrahedral. Now let's talk about bond angles. This angle between these two bonds is about 109.5 degrees. Okay? Same here. 109.5 degrees. All right, let's look at this next one. Now we only have 3 sides of that atom being occupied, and so the electron domains, we have 3 electron domains, they spread out like this. They get as far away from each other as possible, which is 120 degrees. We call this trigonal planar. Okay, and since it's just atoms, it's trigonal planar. I think all these are just atoms, aren't they? We have to do another one of these videos. So here's CO2. There are only 2 sides being occupied, so there are only 2 electron domains. So it ends up looking like this, and that is linear for the electron domain geometry. The molecular geometry or the molecular shape is also linear, okay, because it's only surrounded by atoms. So we'll get to one that's not the same. So that one, you guessed it, it's trigonal planar. Oh, by the way, this is 180 degrees if you didn't guess. So this trigonal planar, which is 120 degrees. All right. And since it's surrounded by atoms, it's just trigonal planar. Trigonal planar, trigonal planar. Okay, so here's one that has actually lone pair electrons, right? So there's 1, 2, 3, 4 sides of the box still being used. So it comes from tetrahedral, but we draw a balloon. I'm going to draw the whole thing. A balloon where the lone pair electrons are. So here are the atoms, like that. So if we're talking about the electron domain geometry, it's tetrahedral because there are 4 electron domains. Right? 1, 2, 3, 4. 4 sides of the box being occupied. But if we talk about molecular shape or molecular geometry, now we're only describing the atoms. So now we're only describing this shape right here. That's the shape that we're describing. And that shape is a trigonal pyramid. It's a 3-sided pyramid. Okay, now, another important point. These lone pair electrons actually repel these atoms more so than an atom would. So where tetrahedral is usually 109.5 between these two atoms, now we can say it is less than 109.5 degrees because these lone pair electrons push these atoms in closer. Okay, so that's why it's less than 109.5. You're going to see that again here. So now, how many electron domains? Oh, that's not what I wanted at all. How many electron domains? 1, 2, 3, 4. 4 electron domains. So the electron domain geometry is still tetrahedral. Okay, but if I go to draw the shape now, there's my central atom. lone pair electrons, another set of lone pair electrons, atom, atom. So in this case, when I talk about the molecular geometry, I'm either going to call it bent or V-shaped. Because again, I'm only describing the atoms. That right there. What angle is this? Well, these are repelling the atoms. These are repelling the atoms. So it's actually what we say less than 109.5 degrees. So in other words, this angle, which I'm going to call A, is smaller than this angle, which I'm going to call B. Right? So that's why we say it's less than 109.5. So the electron domain geometry, you look at how many sides of the box, how many electron domains are surrounding the central atom. Then the molecular geometry is just describing the shape that the atoms actually occupy. So hopefully from the notes you sort of figure that out.